Okay, let us go ahead. We'll get ourselves going today. Oh, we again have another action-packed agenda with lots of hopefully fun things for us to do today. So let's just go ahead and dive on in. At a high level, we want to do a couple big things today. We want to actually talk about 120B, the course for next quarter, and actually think about the content and the time and see if we can try and find a good time. It's hard to find good times that don't conflict with a lot of other classes. So I want to do some polling of you to sort of see, what would be best for anyone who's interested in taking that. We'll also go ahead and continue with just sort of the main lesson content. We're going to be looking at the whole notion of just really creating custom geometry, something we started with last time, started editing some parametric family components last time, but really kind of walk through that and give you a lot of power about how you can create some really interesting components that you'll be able to use as you kind of take a look at the next assignment where you're going to be creating your own components. And then hopefully we'll also get into a little bit of materiality and think about that aspect of objects. We haven't really talked about that very much. We've been choosing materials out of this mysterious materials dialogue that has some thermal and visual appearance and kind of physical properties in it. But we'll talk about how you can kind of create your own and how you assign those to elements. Okay, because there's really an awful lot of power in that, and that's kind of the final piece. It's not just creating the form, but it's actually thinking about what things are made of and how you go through and control that. So let me start with the whole issue of 120B, 220B, and what's going to be happening there. So that is really intended to be a continuation of this class. So if you're having fun with building modeling and you'd like to keep on going, it really kind of just keeps on digging in deeper because we can only get so far in the 20 sessions that we're together here. So here, as we're going through the topics, so for example, on structural analysis or on structural design, we'll spend a session and a half doing something like that. But there's really a lot more to say about that if you really want to know about that. Similarly, for mechanical systems where we start thinking about ductwork and how air is moving through a building, or plumbing systems, so sanitary systems, sprinkler systems, electrical systems in a building, all the different systems that really work around the skeleton of the building to go ahead and really make it a complete functioning organism. That's what we're going to take a look at in 120B, how you do the modeling of those things, but also do the analysis of those things so that using the building model, you can figure out what the loads are going to be based on the occupants and what people are doing, and then how you'd actually size some sort of a building system to go ahead and meet those loads. Okay, so it's a really good course as a complement to a couple other courses if you're planning to take. You might want to sort of take this to go with them. For example, if you're taking the Renate's the PBL lab, the Global AEC class, okay, this class was really designed to be a complement that would really support people who are taking that, because in that class you'll be asked to actually go through and do a building design where you incorporate all those different systems, and this is kind of like the technical tutorials to kind of back up what's going on in that class. Yes?
Do you know when it's planning to meet during the week?
I think that is mostly class or team meetings through the week. Or you mean like we're not this class?
No, your class.
Oh no, that's what we're talking about. We're going to figure that out
Oh,
in just a second here.
sorry, I missed that.
Oh, no worries. So we'll figure that one out. Another good class, if you're taking like the building systems class, Eric's class on just designing building systems, this will be a good class as a complement to that, because everything you'll be doing there conceptually we'll be doing here from a modeling standpoint. So there's it's a complement to an awful lot of other classes. So in thinking about that class, one thing we have to do is sort of figure out a class time, and that's actually one of the hardest things to do around here, because we start looking at the schedules and what the structure students take and what the construction students take and what the undergrads are taking. It's really hard to find class times that don't walk all over everyone else's class times. So here are some possibilities, and I just want to get some sense of the desirability or non-desirability of some of these different times based on trying to avoid some of the things that other people need to take. So these are all potential times that we could go for. Actually, let me even kind of show you what the matrix looks like. I think you guys have all seen this matrix, or at least most of the graduate students have seen this matrix. This is the big master matrix. It's really what's offered next quarter and where the different conflicts are. And the hard part is the key kind of core times, like Tuesday, Thursday, 10 to noon, things like that. There's about 4 different classes that all meet at the same time that you need to take, and it's really hard to kind of squeeze yourself into those. So to try and accommodate people there, I tend to sort of push towards the boundaries on the outside so that we don't kind of get into the middle of things. There's some classes that sort of do funny things where they meet on Monday and Tuesday, which kind of really make things very odd in terms of trying to schedule some other things. But these are some times, just kind of looking through it quickly, I've identified are relatively open. So like the early morning times, Monday, Wednesday, kind of relatively early, 8 to 10 or 9 to 11. About the only other class that's affected at that time are people who are taking 282, the nonlinear structural class. So Greg's class doing that. So that's kind of a possibility. That doesn't seem to conflict with too many people. Another time that doesn't conflict with too many people is in the evening on Monday or Wednesday. So if we go into the evening on Monday or Wednesday, about the only thing we sort of hit up against is, what is it? It's the negotiation class. So if I'm back over in here, it's down here, 251. Engineering economy, which is also offered at that time, you know, there's some other options about how to go ahead and take that. So I think that one's not so bad if you need to take engineering economy. That one's
required for a lot of this construction.
So that one, okay, so that could actually sort of knock that out in terms of a good time there. So that's basically Monday, Wednesday, 6 to 8. Okay, so that one also has sort of engineering economy in that. That's 246. Okay, looking at Tuesday, Thursday on the other hand, you know, the big times that are sort of potential ones that are interesting are, there's always the early morning one. Early morning no one really likes very much, but 8 to 10, the only class that's really conflicting at that point is Gary's infrastructure project delivery, so 241B. Okay, so that's an issue there. There's also, what, Miranda's behavior and design of structural systems, 286. Okay, so that's kind of a problem early. That's for the 9 o'clock time frame. Yeah. The evenings, again, are also possibilities. If we go for the evening, if we went for a 6 to 8, which is kind of what I'm doing with the evening class of this, although we ended up shifting it back to 5, and that's always a possibility too. The only thing we really sort of bump into is, what is it? It's the legal aspects of construction, the 102 class. So that whole kind of, oh, what is it, 5 to, that's just not too bad. Even here, it's 5 to 7 is not too bad. 6 to 8. Am I reading this incorrectly? Oh no, we still have construction claims. So if we went 6 to 8, we could avoid construction claims. If we started at 5, people who are taking the construction claims class would have more of an issue. So Tuesday, Thursday is another thing. Yeah, so I just want to throw all these times out, and really at this point I'm just collecting people's feedback about when you'd like the class to be. So how about this? You know, do we have any sense, just even now together, while we're all in the same room, because we could always do it sort of remotely too, but you know, I could put out a doodle poll for that matter, in terms of different times. Actually, why don't we do that? Would that be the best way to do it, Lottie?
Yeah.
How about that? Okay, we'll have Lottie go ahead and send out a doodle poll. Thank you, Lottie. Kind of like offering some different times, and really at this point we're just trying to poll to see what's going to meet the most people's needs. Yes?
Will you still be videotaping?
We will still be videotaping, so that'll still be an option if you're missing in part of one of the classes because it overlaps and stuff like that. You know, a lot of people say the videos are actually better because you can fast forward right through me and get to the important stuff. So, yeah, that's okay. I'm quite okay with that. So, okay, so let's do that. So, Lottie, make a note of these guys in terms of potential times, but really, you know, anything that we can think of, we're just going to put it out there because we have to decide on class time. So, if you are interested in the class, please do this. Go ahead and sign up and access for 120B. It just says time to be announced or something like that, or to be decided. Just go and get yourself in there so we know how big the class is going to be. And then from there, we'll go ahead and figure out the timing. Okay. Sort of make sense? Didi. Okay, we'll leave it at that for now. But it's really, I challenge people to find good times that don't conflict. Yes?
Another thing is some of those might change. You're like on Axis right now for course development, but 246 doesn't even have it. It says the time to be as.
Ah,
So,
and that's the engineering economy ones?
yeah. Definitely check that out for everything.
You love moving targets when all the pieces going to continue to go around. And we're changeable too. Okay, so, well, thank you for sharing. No, it's part of the complexity. It's all these moving pieces. We'll try and figure it out. Okay, but the intent is, well, let's start with this. Do people have questions about what's in the class? Let's start with that. Does that sort of make sense? Okay, so super. If it sounds interesting, you're having fun with building modeling, and you want to keep on going deeper and kind of dig into it further, like please go ahead and sign up, and we'll get you set up. Yes?
You said something about 256, but I think they have, do they teach anything about Revit in that class, or will you be teaching?
Now, it's really, in terms of the building systems class?
Yeah.
Yeah, he's going to be teaching the design principles and really kind of the good elements that are part of a building system, and then we'll be going through and doing the modeling that shows you how you go and implement that in a building model. Okay, so it's it's actually a pretty good 1-2 punch if you're interested in that area to kind of like get them both, because you get all the principles, but you also get the.
Is this class like a prerequisite for the lead, or can anyone take this?
No, anyone can take it anyway. It's like I'd say the two are highly complementary. Okay, but you don't need to for the 120 or 220 or whatever our current number is. Okay? Beautiful. Okay, let's go ahead and turn our attention to stuff that we want to talk about today relative to this class, which is really all about this notion of we're going to keep on going with creating custom geometries. And we sort of started digging into that just a little bit last time as we looked at the whole notion of really, moving from in-place families to ones where we can actually add components to them to allow us to stretch and resize and do all the things that we'd like to do to go through and make them more flexible and more shareable. Okay, so as we get going with all that, the important thing as an overall kind of workflow that you have to sort of understand is that it really is very, very similar to what we were doing when we were creating in-place components. This whole notion of extruding, blending, revolving, sweeping, all these basic mechanisms for getting started creating different types of forms, that's consistent. It sort of works across almost all 3D modeling packages. There's sort of that basic way of getting going. What we're going to do that's a little bit special in terms of making these objects resizable and reusable is we're going to go through and just create them in a slightly different way where, as opposed to going through and just saying modeling in place, we're going to go through and say, let's create a new family, and within that, we'll still choose a family category. Everything has to belong to a category so that it sort of has a place to live in the object hierarchy. And we're going to set up something called reference planes, which is going to give us a lot of power for going through and resizing objects. Because what we're going to start doing is really defining the boundaries of objects through reference planes, and then lock the sides of geometry to those reference planes. Okay, so it all gets to creating reference planes that'll really be the bounds, and then stretching and moving those around. Okay, so as we get going, we're going to be using parameters to go through and control all sorts of different things. Using the reference planes, we're going to set up dimensions to control where the reference planes are. We're going to add some parameters, okay, to the dimensions that'll determine the reference plane location. And then finally set up different types of families that have different groups of parameters kind of really loaded into them. So it's probably easier to kind of just show you how it all works. So let's start. Well, actually, we didn't do this very much. Let me kind of come back over here, and I'm just going to open up some existing Revit families just to give you a sense. It's always good to sort of do a little bit of debugging. I think we did this a little bit last time, but let me go into it just a little further in terms of, hang on. Let me go out to the Revit library for right now. So if I go out into the Revit library and I go through and I look for some different pieces, there's all sorts of different pieces in there. And I think we did this last time in terms of just looking at the desk or something like that. Let me just see if I can open up something else that's a little bit interesting. I'll open up a piece of casework. Okay, and I'll open up a base cabinet. And let's go for like a double door thing. So again, what I like to do is often just go through and just look at objects and see how they're defined. See if we can sort of debug how those are constructed in terms of where the extrusions are, where the blends are, where the sweeps are. See if we can kind of figure this guy out. And the way we always do that, either to sort of do some debugging or even to modify it because you want to change the appearance, is as follows. You sort of choose different objects. What I did was I just opened a family as opposed to inserting or loading the object family. Okay? And if I go through and hover over something, you can actually see, well, that's interesting. It's considered a sweep. I'm sort of, looks like that might have been able to be done as an extrusion, but let's think about how it got defined as a sweep. I'll choose it, and if I say edit the sweep, we can sort of see That's interesting. Okay, it is a boundary. It's kind of sweeping around, and it's just this like tall profile. So like it's a rectangular profile that's going around. Let me orbit that around a little bit. That might be a little easier to see because I think it's on top of it right now. You can't see it exactly.
Wouldn't that be much easier to do as an extrusion?
It probably could have been done as extrusion. You know, there's always different ways of doing it. So I probably would have first done that as an extrusion, just an extrusion with a hole in the middle. Yeah, so something like that and kind of stretched up. So I think that would have worked too. Yeah, this might give us some flexibility if we had some parameter that wanted to bow it out or something like that. We had some sort of curved surface that we wanted to really kind of just sweep that cabinet side around. But yeah, I think I'm with you. I probably would have done that with the using more of a extrusion. Let's take a look at the bottom here. That looks like that was done with an extrusion. So looks like that's even a simple extrusion. That toe area of the cabinet is really just extruded up 3.5 inches. It's just like a solid block. It may not even be accurate in the scheme of things because it probably would be hollow down there. So there might be, you know, some reason to go through and do something like that. Let's close that back out. Let's take a look at those drawer faces, cabinet fronts. Those are all, I'm betting, extrusion. That looks like what it is. What they've done is they've just drawn 4 profiles right on the cabinet face, and then they're extruded out some sort of like 1/2 inch dimension just to give them a little thickness.
To do that, did they put a plane like in front of the cabinet?
Exactly.
face?
They put a reference plane right on the cabinet face, and that reference plane is doing 2 things. It's controlling the depth of the cabinet, but it's also then the plane on which we're drawing the extrusions. So reference planes are really the key to all this. You know, think about everything in terms of planes. In fact, let's show you those in just a second here. Let me do the handles, the last thing over here. What are they, would you guess? I'm guessing those are extrusions. Okay, just right on the face. Okay, again, well, this is on a different plane. This is on the plane which is the front of, not the cabinet, the front of the cabinet faces, or the cabinet doors. Yes. Okay, so let's take a look at how that's actually defined. Okay, if I look at it from the top, you can actually start to see all these different sort of reference planes. So, for example, we have the back of the cabinet, we have the front of the cabinet, and there's a depth right here of 2 feet. So this is the plane upon which, okay, these cabinet doors are being drawn. Okay. These planes are sized by going through and putting a label on the dimension that gives us the ability to kind of make it 2 feet. So when you go through and you say you want to give it a different depth, 1 foot or 3 feet, what happens is when I put in there that the width is, or the depth is 1'6" as opposed to 2 feet, what actually happens is the green reference plane moves back and then the geometry moves with it. So you got to get used to this idea. We're always moving reference planes and dragging geometry along with it. Okay, so our first task is always just get the green reference planes to move around right. Okay, and if we get that down right, generally the geometry will follow along pretty well. Okay. If you want to go through and, let's talk about some of the other ones that are in here just so you can sort of see the interesting dimensions. There's the width of the cabinet, that's the 3 feet. That's looking pretty good. You understand what that one's all about. Toe height, that's actually a parameter. Let me kind of switch over to the elevation. You'll see where that's used. It's actually there's a reference plane right there at the bottom. Well, I'm not seeing the dimension. It must be, it's here in one of the views. We just have to find where it's defined. There it is, toe height. So that reference plane on the side, that's determining why it's 3.5 inches tall at the bottom, how big that one is. So there's all sorts of reference planes, different things that are sort of driving it. Now, as you get going with families, important things you can do. You can open a family, and if you just want to change a family, super, go ahead. That's really a good way to get started. For example, if you don't want door handles on your object, you can take the object and just start knocking them off. That's okay. There's no reason, if you want a cabinet that has no door handles and there's one that does have door handles, there's no reason you have to go ahead and create that all from scratch. Okay, start thinking creatively about how you can adapt things to be what you want. So if I want, for example, a cabinet that has glass doors in it as opposed to solid doors, I might take this one and just adjust kind of the profiles or adjust the extrusion. Let me I'll put the door handles back for a second, because I'm going to use them in a second to do something else. So I could take this extrusion, I can edit it, and if I want to have something that looks more like, oh, some opening in the door, I can add an opening in the door. Now, I'm putting that opening in there very dumbly right now in that it's not going to resize. I'm just drawing it in there. I would want to put some parameters in here to control the width of the rail all the way around. But you can go ahead and just make simple little adjustments to cabinets like that. Okay. And now you have something else. So go ahead, don't be shy about grabbing other people's parts, opening them, debugging them a little bit, and just making changes you want. Okay, so that's certainly within the scheme of things we can do. Yes?
Can you adjust the width when there are other elements on the object that would be affected by the width change? Like if you change the width of the cabinet to make it smaller, how would that affect it?
Oh, because we haven't put any smarts in about where I do that, I just kind of threw it on the cabinet door. It won't be smart yet. So let's go ahead and I'll make that 5 feet wide. Well, actually, that was much smarter as an assumption than I would have guessed it would be. Okay, it's getting smarter. It's interesting. For lack of a better thing to hang to, it's figuring out what the relative distance to the end is. Yeah, I'm amazed that it did that. That's, yeah. What I would usually think about doing is actually adding some more reference planes and be very explicit about controlling that. But in this case, we got lucky. Yes?
How would you have to use a curtain wall if you want to put glass on those extrusions? Glass?
No, we could actually do something a little different. The curtain wall would work, but actually we can just make an extrusion out of the material glass. And that's the way to do it. So for example, we could, let me go ahead and say we're going to make another extrusion. Okay, extrusions always have this issue of, well, okay, you're going to draw an extrusion. What is the work plane? What is the reference plane we're going to draw on right now? And currently it's set to the ground floor, okay, which is not good. So if we draw right now, it's going to draw down on the floor of the cabinet, and we don't want that. What I'm going to do is actually set a different work plane, which will be, reference plane front. I'm going to guess that's it. I should actually go in and kind of look. Every reference plane probably has a name, but let me just guess it's this for right now. So I've just drawn a little extrusion right there. Hopefully that's about right. What I can actually do is give this a material. So I can say I want that to be a glass material and slide it in there. Okay, right now, it sort of has an extrusion distance that's a little bit funny because it's going from half to 1. What I probably wanted to do is go from 0 to half. But again, I'm doing this kind of relatively manually. But okay, let's see what that actually looks like. That's not too bad. I've been very sloppy about doing it. Looks like I sort of missed on the top there. When I'm drawing extrusions like that, you shouldn't really, I'm doing it quickly in 3D. It'd be better to actually do it directly in the front view. So let me switch over here. You can see that here's my piece of glass right there. I really need to have it join this line up here. So this is actually a good, okay, this is actually useful. You got that line there, you want it to join up to here. You would really love to have that always follow, the glass always follow the edge of wherever the wood ends. So the way to do that is to do an align, grab that, then grab the edge of the glass and lock it. And now the glass will always follow the edge of wherever the wood goes. Okay, so you can get started just sort of really quickly sort of modifying things. Let me show you another kind of cool parameter. So we're going to control parameters in a number of different ways. We're going to put parameters in there that control size. So all these dimensions to kind of push things in and out. They're pretty good. You're going to put parameters in there that control material. Okay, so you can choose the material of any object, whether you want it to be wood or glass or whatever it is. We'll add those kinds of parameters. A third kind of parameter I'll let you know about is actually one that just controls visibility. So for example, if you have a cabinet like this and you want to have a version that has handles, and you want to have another version that doesn't have handles, I could make two separate library parts. I can make with handles, can make it without handles. Okay, but you really don't need to do that because the issue of whether a handle is there or not could really just be a parameter. Okay, and how you do that is as follows. When I choose those, you'll see there's actually a choice right here of whether or not they should be visible. Okay, and that seems kind of strange. Like, why would you make it not visible? But if you want to have something that can or cannot be a feature that can be turned on and off, we can control that. And by default, it's set to visible. If I turn it off, okay, they're kind of grayed out right now. As in, when I load that into my project, it won't be visible. But it's kind of leaving them there just to show me that they do exist. They're just kind of hiding in this invisible form right now. So that's not too bad. But what I would really like to be able to do is actually have a parameter that lets you really easily change that, not just kind of have a single setting. And let me tell you how you do that. Go back over here. For all the parameters, for example, this visibility parameter, hanging out over here just to the right, there's a little bit, or the button there that'll let you associate a parameter with that property. And we'll show this in more detail a little bit later, but there's this whole issue of whether or not this should be visible. And what I'm going to do is just add a parameter that'll let us control that. So we're going to put parameters in that control dimensions, but let me show you how we can actually put one in here. I'll just call it handles visible. Okay, it's going to be a yes/no parameter. They have different types of parameters, dimensions, materials, yes, no. And if I put that parameter in there, okay, this is now controlled by the parameter. Now, what happens when you make something a parameter? When you make something a parameter, all of a sudden in the family types, okay, it shows up as one of the choices there. So not only can we change the dimensions, we can actually control the visibility there. So what's good about that? I could say that I have a 36-inch right here, renamed with handles. Okay, and that has this property. Let me duplicate that. I'll say 36-inch without handles. And for this one, I'll turn that off. So I now have the choice of either with or without. And I can go through and control that just by changing the parameters there. So now people who use your family can control whether or not it has handles just by changing that parameter. So all of these parameters, as we're going to learn, there's a choice between things that are handling at the family level or things that can handle on a cabinet by cabinet basis. But that's where we're getting to. So, yeah, if this is all going by fast now, don't panic yet. We're going to build up to this, but this is where we're going. Okay, so by the end of the class today, you should be able to do this for your own parts. Okay, but how's that feeling as an overall kind of notion that you can make parts and we can use these parameters to go through and control the width or the dimensions, to control the materiality and also control the visibility? That feels sort of good? Neat. Okay, let's go ahead and do it. So that's where we're going. And again, don't be shy about grabbing other people's parts and using them as a starting point because it's a great way to get going. Okay, so as we go through and create parts, let's talk about what we're going to do. We are going to say new, family, and the first thing we're going to do is choose a type. All the type information really comes out of a family template that you choose. So let's talk about these for just a second and really what some of our choices are. There's this big issue of really what category things belong to, and that's pretty good. You sort of figure out, oh, it's a piece of furniture, it's a piece of casework, it's a piece of whatever you want it to be. Okay, so that's okay. We choose the overall category. Slight variation I want to let you know about is this notion of whether or not something is based or hosted on something or isn't. Let's look at the electrical fixtures. Maybe that'll be the easiest example. Okay, if I go through and I'm designing a lamp that's going to sit on a table, okay, I would probably do that as just an electrical fixture, okay, because it could sit on pretty much a table anywhere in the room. It could sit over here, it could sit over there, a floor lamp, same sort of thing. I could set it anywhere. It's not really hosted by anything. It has complete flexibility about wherever it can be. So just things that don't really say based have this notion of you're just going to put them anywhere you want to. You have complete control, X, Y, where you want to put them. Okay. Ceiling-based fixtures, okay, need to live on ceiling. So you have to have a ceiling to put them into. So these guys, you know, these lights in here, the big troffer lights in here, oh, that camera which is hanging from the ceiling, these speakers, these are all ceiling-based objects. And how does that actually work? Really, it just sort of, as we're creating them, you have a little template or a placeholder ceiling. You define your object, and then as you place your object on a ceiling, it'll insert it into whatever ceiling you put it on. Okay, so we have ceiling-based objects. The other kind that we use a lot is wall-based objects. So wall-based objects are like sconces. Like this camera over here, that's a wall-based object. It needs to be hanging on a wall. Light sconces, oh, what else? I don't know. Just things that stick to walls. Okay, wall-based fixtures. Yeah, and again, what happens there is you get a template wall, and then we use that as a starting point. So let me even kind of show you what that looks like. If you choose a wall-based component, and that's not what we're going to do right now, you get a wall. Okay, a placeholder wall, and then we start basically defining things on top of that. So great, we come on top of here, I'll make some sort of extrusion for some nice light fixture here. Let me change the reference plane. Actually, let me just do it on the front. The placement side is the side of the wall as you're placing it in there. Let me set this to, front. Now I can draw something. I'm just going to draw some nice, like rounded thing. Oh, ba 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 bum bum bum. Going to pop that into 3D. Looks like I'm about halfway in and halfway out. Let me look at it from the top. Okay, now it would be sitting on the wall. I'm not going to add any parameters to it right now. But there it is, kind of hanging out on the wall. So now if I go ahead and bring it into my project, it'll stick that onto any wall that I'm choosing. Okay, so wall-based hosted things, it's really just get a template of one. And you might even recognize that wall or doors and windows actually are examples of things that are hosted that way. So for example, if I say a new family, see if I even have a door. I do have doors. Or, no, hang on. New. So for example, if I choose the door family, you'll see that what happens, or template, you'll see it already has built into it. Let me change the scale. Oops, wrong way. Okay. It basically has kind of a hole cut out. Actually even has sort of a door panel put in there right now. But if we wanted to go through and customize this, we could do things like, oh, edit this. I can make it a groovy arched opening or whatever I want to do there. That's just kind of a different kind of piece of trim. But you get a template wall that you put things in, then you start sort of adjusting the extrusions on that to kind of make it whatever you want it to be. But let's go ahead and for what we're doing, let's make something relatively simple to get going. Let's make some piece of furniture. That's often an easy one to sort of understand. And let's see if we can design something and make it make sense. So I'm going to say new project or family. We'll go down into the templates here, and let's find just the furniture one. Open that up and see what we get. So again, new, family, and choose the furniture. And we're looking at the top, and let's talk about what we're seeing here. Okay. What we're looking at right now are these two reference planes. This is the front-back reference plane. That's the left-right reference plane. So this point right here, right dead in the center, that's the insertion point. So when you insert it and you're dragging it around, that's the point where it's actually, your mouse will be clicking. Okay. So relative to that, let's design some piece of furniture, and let's say I'll take any and all like suggestions. Go ahead and like, what kind of furniture, what piece of furniture would you like to design? Don't be shy. Oh, that? A couch. Okay, let's go for a couch. So let's think about our couch. Okay, our couch can be a couple different ways we can make a couch. Like, oh, if for example, so one thing you'll figure out really quickly in this class is I can't draw in 3D very well at all. Okay, so depending on what we want to do, we could go ahead and model this a couple different ways. I could think about just making an extrusion for the base cushion. Okay. I could make kind of a relatively square back top cushion in there, and then maybe I'll just put some handles on the side. In fact, I think one of the couches basically does that. Oh, is that a bad drawing? Okay, you sort of get the idea. I basically have one extrusion here, I have another extrusion here, and I have these two handles, so these extrusions on either side. And that's one way to do it. If it's all sort of very squarish, okay, and perfectly vertical, extrusions are great. If I want to have more of this tapery, I can lean back, I might do that as a sweep, as opposed to doing it as an extrusion. Yeah, I can still go ahead, this might be a sweep that comes along like this. My handles will probably be about the same. I'll probably still do those extrusions. Or my arms, on both sides. Okay, but let's go for this. We'll go for that to make it real simple as a starting point. We can morph into that. Okay, so as we go ahead and work, we're going to set up this basic geometry in that system. And the way to do this is we're going to actually define some planes that are going to help us get going. So for example, this whole notion of really the distance from here to here, just the width of the cushion, I'd have those as two planes so that I can control the width of those different things. I'd probably have another plane here and here, which just lets me control the width of the arms in addition to the cushion. Make sense? Same thing over here. I might just have plane and plane here, which let me get the front and the back. I can get a little more detailed if I want the arm to stick out even further, but we'll keep it simple at first. Let's just kind of work with these. Okay. Let's talk about this thing vertically. So horizontally, or in a plan view, those are the big planes I'm probably going to do. So side, side, front, back. Okay. If I looked at this in a plan view, it probably looks something like this. Okay. So in terms of what we have going on here, I'm probably going to have a plane at the back and a plane at the front, and that'll determine the cushion size as well as the arm size. And I'll probably put another plane kind of right here, which will let me control the depth of the cushion. Okay, finally, if I look at it from the front, so there's the arm, there's the top, there's the other arm over here. Probably looks something like that. And what I'll probably do here is say there's a height of the couch over here. Maybe there's the base of the couch, or that's the floor right there. Maybe I'll do that level right there. That's going to be the bottom of, or actually, maybe I should do it the other way, the top of the cushion. Could be the bottom of the cushion, either way. But that's my sort of strategy. Always think about what it is and what planes you're going to need to draw it. Does that make sense? Okay, let's see if we can make that all make sense relative to this. Okay, so we're in our drawing area. We're looking at the plan view. So we're going to be doing this stuff first. And as we're drawing planes, here's what we're going to do. We're going to go to the reference plane tool. So over there in the datum section, go ahead and, where is my mouse? Do I leave a mouse hanging around over here? I did leave a mouse, thank you. You could be mysteriously controlling things on the screen, freaking me out, and I would never know what's going on there. Okay, so we're going to go through and grab some reference planes. We will put a reference plane on. It's going to put one over here. Let me work on the sort of the overall issue of the size of the couch. And I'll put one on the back and one on the front. So I'm going to start just by boxing this thing in. We're going to add some more to it, but that's the front and the back as well as the two sides. We'll handle the arms in just a second here. Okay, so I got these planes here. I would like to be able to kind of stretch and move these planes to control things so the width of the couch. And let's talk about how you do that. You set up dimensions that'll let you move the planes around. Okay, then you add parameters to those dimensions, which then make them just text labels that you can sort of drive the dimensions with. So let me show you what that looks like. That was a bad explanation, but I think you'll see it in a minute. Okay, we're going to go through and put a dimension all the way across here. Okay. I am going to call that dimension, give it a label. So it's not just 7'1", fixed for all time. I'm going to add a parameter to it. And that parameter is going to be, I'm going to call it the length of the couch. Now we have the choice as we're putting it in here. It knows it's a length. You can figure that out based on what we're doing. I can make it a type parameter or an instance parameter. And let's talk about what that's all about. If you have a type parameter, you're going to have a type which is a 6-foot long couch and an 8-foot long couch. Okay? And we can have lots of different instances of 6 and 8-foot long couches. If I make it an instance parameter, then every individual couch, this one's 5'3", this one's 5'6", this individual one's 5'2". It's really just, do you think about them as families or do you think about them as individual ones? And for furniture, generally, that we tend to do as families. Because you order them out of a catalog. You know, there'll be a 6-foot couch, there'll be an 8-foot couch. You sort of get a couple standard sizes. So we'll say length. Put that on in there. Okay, we got a length. Now, before we go much further, and I'll advise you to do this as you're building your things, build things up slowly but surely. Kind of really, as you're adding more and more things, it's kind of like a visual programming language in a way. Test things and debug things one step at a time. So, in this environment, you have the option of family types, which shows which parameters have been defined so far. So I'm going to say, you know, 7 foot looked pretty good, but let me just see what happens if I make that 8 feet. I'll flex it. I'll say apply, and it seems to be moving. Okay, that's not too bad. Let me go ahead and make it 5 feet. Okay, and it's moving in. So we're getting the right behavior in terms of stretching. That's feeling pretty good. You might notice, though, that something else is kind of happening that's a little bit weird, though. And that is, as we're moving things around, if that's my center point, okay, it's not doing a good job of honoring that as a center point. It's kind of moving around. It's stretching one side or the other. I'd really like to be locking that as the center point. And to do that, we're going to add another kind of constraint or another dimension to it that'll create that behavior. So how that works is we'll say annotate. I'm going to basically run what's called a string dimension, 1, 2, 3, across. Okay, and because it's a string dimension, you'll notice that up there at the top, there's a little EQ with a slash going through it. They're not equal right now. If you turn that on, okay, they'll always be equal. And what's that all about? All I'm trying to do is, as I go through and enter a dimension in here, like 8 feet, is always make sure that it goes to either side. So two things. Go ahead and get the length parameter the way you want it, but also get the equality in there. That way it sort of stays centered on what you like. Now, if you can handle this notion of the length and how we did that, okay, you're going to be just fine on the width because it's going to look, or the depth. It's going to be just about the same. Let me go ahead and say OK to this. And we'll do the other dimension too. We'll say, let's go ahead and put a nice string right in here. I'm going to call this one, okay, what I do is I put the dimension in, then I choose it, and in the little options bar, you can say add a parameter. I'm going to call that the depth. But since I want that to be even, let me go ahead and go one step further and put a dimension in that's all 3 lines. So I can just give it that little equality. Okay, and I'll do the same thing. Oh, let's stretch it so the depth is more than, what are couches? Well, they may be 2 feet. 2'3". If they get much deeper than that, you can't really sit on them because your knees are out too far and you have to lean back and you can't really touch the back. I'll apologize to furniture designers in the room. I'm just making up dimensions, but those are probably pretty close. Okay, so we actually are doing pretty good. We got this front, back, we got the left, right. We're doing okay. Let's go ahead and we're going to add another reference plane to this, though, to control the issue of where those arms end up, okay, relative to the end of the couch, because we'd like them to kind of hang around too. So we're going to go to Create, Reference Plane. I'll just put some inside. Now, this is just sort of a design decision. You can decide as you're measuring the couch to consider the arms as interior to that dimension or exterior to that dimension. Either way, doesn't really matter. You can sort of just figure out whichever way makes the most sense to you. I'll do it on the inside because people like to think about the total length of the couch and the arms just sort of get subtracted out of that. Now, for this dimension, okay, I would love to have, as this couch gets longer, I'd love to have the arms move with it, so they're always a constant dimension to it. Okay? So I can do that a couple different ways. I can put a dimension in here from the outer reference plane to the inner reference plane and give it a fixed distance. If I did that, then for all the couches I define, the arm would always be 6 inches or whatever I define it to be. Or I could go through and put a parameter on it, just depending on how much flexibility I want to give you. If you want to have, some people have a wide arm couch and also give you the ability to have a narrow arm couch, you can go through and do that. So how that works is same basic operation. I'll put a dimension here. Okay, if I leave it fixed like that, it's going to be 5 7/8 or 6 inches, whatever it is, for all time. It'll always be fixed that way. If I add a parameter to it, though, and we call it the arm width, okay, then that'll be changeable. Now, when you have a dimension or a parameter controlling one side and you want to use it somewhere else, for example, I probably would like the arm width on the left side to match the arm width on the right side, or the right side to match the left side. I can just choose an existing parameter and associate it with 2 different sides. Okay, so what I did was, again, I just chose that dimension and I said, you know, I'd like him just to share that same parameter. Okay, so before we go any further, let's go do a little testing, because we always like to test this stuff. And I'd like to say, okay, let's just test all these different things. What if for the arm width, instead we put like 0'2"? Okay, see how it looks? Looks like it did pretty good in terms of shrinking them up. Let's go ahead and we'll move the length of the couch so it's 6 feet instead. Okay, and the 6 feet's honored, the 2 inches is honored, everything's looking pretty good. And that's really the game here. It's really just to kind of get these green lines moving around. If you get them moving around the way you want, you're going to be in good shape. Okay, so far so good? Okay, if you're liking that, let's go ahead and just OK to that. Now, because I've been working so hard and you know my computer's about to crash, I'm going to save this so that I don't go ahead and lose all the hard work that I put in here so far. So go ahead and put that out somewhere that makes sense, and I'll just go ahead and put it in my Stanford session 11. I'll go ahead and put it in my couch morning. Are you ready to use it? Now, so far, we've been pushing a lot of green lines around, but you might say this doesn't look very much like a couch just yet. It just kind of looks like a bunch of green lines. And we can fix that. So let's talk about how we can. What we're going to do is we're going to start actually defining some extrusions now to sort of fit within those boundaries. Okay, and just stretch them and lock them to those boundaries. And let's see if we can make this work. How about, I'm going to do the little bed area, the base of the couch, and I'll do the arms first. Then we'll go back and add that kind of back to it. But let's see if we can like make just a bench out of it first. In fact, that might not be a bad family, because then we could have a bench version or we could have a couch version, just depending upon whether you want the top or bottom. So how we do that is we say create, and now we're going to create some of these forms. So I'm going to start with just sort of a relatively squarish extrusion or a rectangular extrusion. I'm going to just put it right here in the middle, and you're going to notice I'm doing something that's going to seem very odd to you. I'm drawing it, but you'll notice I didn't go through and draw it to the green lines. And there's a reason for that. If I draw it right on the green lines, it'll probably grab the green lines and lock to the green lines, but I'm not 100% certain. Okay, there's always that 10% chance that it didn't quite pick up the relationship that I had in mind. So what I tend to do is I'll actually draw things away from the green lines, and then I'll use the align tool to lock them in there very explicitly. Then I know, very 100% certainty, those things are going to lock. So let me show you what I mean. So I've drawn that. That looks pretty good. But I'm going to use the align tool now, and I'll choose the green line and lock the back to that line, the side line and lock it to that, the front green line and lock it to that, and this side. And again, I'll lock it to that. And again, why am I doing this? It's really just to be very explicit. I want to make sure with 100% certainty, or 99, that it's actually going to lock to those things. So as opposed to just letting it implicitly happen, I like to get real explicit. Okay, so we did that. We need to go through and give our extrusion some sort of start and end, and we'll just sort of put some manual value in here. We'll later figure out how to make that a parameter. Let us say, oh, it's going to be like, 6 inches off the ground to 1 foot off the ground. That's pretty fine. We can give it a material here if we want to now too. What do we have? Not very much going on in there. No, we'll save materials for a little bit later. Let's finish that up. Okay, now so far this is not going to be very exciting. Let me look at it in 3D. It looks like just a big old block of foam that you're going to be sitting on. But if we try to resize it, and again, always flex and test and make sure things are going good. Let's say, okay, you got a big old block of foam. Can I make it an 8-foot block of foam? Can I make it a 4-foot deep block of foam? Okay, can I make it a 5-foot block of foam by 2 feet? Okay, so far so good. Stretching around, beauty. So always build it up one step at a time. Okay, we got that base piece done. Looking pretty good there. Let's put the arms on now. Okay, as a starting point, these arms we were going to do is sort of a simple extrusion again. Oh, let's see what we have in mind. What I will do is, again, creating extrusion, and again, purposely making it not the dimensions I want it to be so that I can lock it into the dimensions that I do want it to be. That was really bad. Okay, let me trim that up. Let me do this. As we're doing the arms, if the left arm and the right arm are always going to be the same material and always going to have the same start to the extrusion, okay, you might as well just make them a single extrusion. Okay, and we can do that just by having 2 loops. Okay, 2 loops is okay. They can't overlap, they can't have holes, all these things, but they can't be 2 loops. That's okay. 2 boundaries. I'll do that same sort of locking. I'll say, let's lock the side of the arm to the green line. I'm not locking it to the side of the cushion, notice. I'm locking it to the green line. That'll happen to be at the same place, but it's the green reference line, which is really the important part. Okay, for the outside, I'll say here and lock that. I'll say this one and lock it to there. I'll lock that to that. I'll lock this one to that. Now this front, for now I'm just going to lock it to the same front there. Again, I could be more elaborate in my design a little bit later if I want to have those overhang a little bit. But keep it simple at first. You know, don't overly complicate your parts as you sort of build up your skills. Okay, see how I lock those all in? That feel pretty good? This will start, let's say, at 0 right on the floor, and these will go up to maybe, oh, let's say like 1'8". Not 18 feet, 1'8". Apply. Let's finish that off. Okay, kind of looks like a bench. This could, a little bit of stretching, this could be a bed. This could be all sorts of different things. Okay, we'll go through and try changing that. Okay, here's the magic test, 7 feet. Woo! Okay, 4 feet back. Score. Arm width. Oh, big, fat, chunky arms. Lovely. Okay, you got a nice resizable object here in terms of what's going on. Let's save that away. Hold that thought for just a minute. Let's go ahead and break ever so briefly. If you can come on back in, oh, try to come back around 10:05 if you can. We will continue. We'll put that back on this thing, and we're going to go through and control the issue of the heights of all these things. So 2 different things. We'll look at it in elevation and in plan so that we can go through and control those other things and learn how we start putting materials and things that turn on and off in here.